This presentation was created for the basic NASIS class. It's created to answer some of the questions that the soil scientists have about how and when this NASIS data was created. We're going to answer some of your questions in this by giving you a history of the soil databases. Even before 1972, there was a form called a Soil Survey Interpretation Record, and it was part of the official series description. What this record actually contained were the engineering properties and the interpretations for that given series. Each SSIR page was attached to the OSED and was part of the official information for that. Here's an example of the Mimosa series, the Soil Survey Interpretation Record. This is dated December 1968. You'll notice that this was a typed product that contained all the estimated physical and chemical properties for the Mimosa series. You'll also notice by looking at the information here, it was tailored towards the engineering aspects of the soil. Here's another example of a soil survey interpretation record, and this one's for the Otero series dated in 1971. You'll notice we've got the short description of the soil along with the estimated properties. Take a close look at your properties. You've only got one set of properties between 0 and 60 inches. And at the very bottom here, you'll notice that we've expanded in the 1971 to include some of the other properties, other interpretations, and plant species. In 1972, the Soil Survey Division entered into the computer age, and what we created were the Soils 5 and the Soil 6 forms, and this data was stored on the mainframe at the Statistical Laboratory in Iowa State University. In 1974, the purpose of these tables were to generate the manuscript tables so that we would have a set of tables for soil properties that we could include in the soil survey reports. Initially, all the data processing was done locally at ISU, and we sent hard copies back and forth between the offices and the Iowa State lab. The Soils 5 forms and the Soil 6 forms were used to enter the series information and the map unit information. And what we did was we created those forms, we mailed them over to Iowa State University. They input them into the mainframe. And then when it came time to generate manuscripts, we would then send the Soil 6 up there to identify the information that was to be created for that particular component for that particular map unit. Now what you have here is an original Soils 5 for the Cecil series, and you'll notice that this was a form, and we took a pencil and we went in there, or a pen, and we wrote in the properties that we were wanting, and then went down and dropped into the interpretations and then put in the interpretations that were to be identified for each series, or in this case, if you'll notice, it's down to each phase. So we've got a 0 to 15 phase and a greater than 15 phase on some of these interpretations. So here is the original information that you see for a Cecil series interpretation record. So now keep in mind we're back in the very early 70s, and here's an example of the Soils 5 form that we created. This was an input form, and this form was used to populate the soil properties that we were identifying at that particular time. This form would be filled out just like you saw in the Cecil earlier. We would mail it off to Iowa. I would then put it into the ISU statistical lab. They'd key punch all of this into the mainframe. And then when it came time to build reports, we would have this information for a particular series laid into the computer that we could retrieve information from. Here is an example of the input form that we call the Soil 6. And this was the map unit record. This came about around 1974, 1972 to 1974 time frame is when we were beginning to get into the computer age. And you'll notice looking at this that this is all geared towards a particular map unit within the soil survey area. This was an input form just like the Soils 5. We would fill this out given for a particular survey area, a particular map unit, and the particular components, and then that would be mailed to Iowa State. And when it came time to create reports, we would then have the information necessary for the map unit and its components, and then we would also have the Soils 5 for the data that we would be able to need to retrieve to populate the reports. As with everything we do, this Soils form tended to evolve into a 4-page document, and additional fields were developed for the series phase criteria and for additional interpretations that we were developing. This particular Soils 5 is TX0249, and that is the Vernon series. And what you can basically see in the background is the first page that you've looked at already. The second page comes up, the third page, and then the fourth page is where you can identify the common plant names along with some of the other wildlife interpretations and windbreak species. So you can see that this continually evolved from a 2-page document, well actually a 1-page to a 2-page and now to a 4-page document. Now let's take a closer look at this Form 5, because you need to realize some of the restrictions that we had placed upon us. First thing you'll notice is that we were allowed three surface horizons on a Soils 5. And we also had lows and highs. You'll notice nowhere on this is there an RV value. Take a look at the sieve number 4 and you'll see it's 95 to 100. There is no RV values on this. We were limited to a maximum of 6 layers that could be used on this particular Form 5. So if you used all 3 of your surface layers, then you could only use 3 subsoil layers. So everything had to be grouped, and we had to aggregate all of horizons into the groups of layers that you commonly see in the database now. Well, that was the Soils 5. Now here's the Soil 6. And you need to realize that once again this form was a data entry form, and we filled this form out and then we handed it off to Iowa State. And the purpose of this form was to retrieve the property and interpretation tables for soil survey manuscripts. And we came in here and we entered in the information necessary for that particular survey area. We have in the soil survey area name, we have the particular map unit, and we put in either the field name or the publication name. We were allowed a total of 3 components within that particular map unit. And so typically only the major components, named components, were put on this form. And you were also allowed to adjust the depths of the horizon layers that would be converted from the 5, because keep in mind the Soils 5 had layers, but what we did is we adjusted them on the Soils 6 in order to get the matching between the layers on the TUD, the taxonomic unit description, and the information that we wanted to be able to pull for our reports. Now all of that between 72 and 85 worked quite well for the purposes that they were designed for, which was to create manuscript reports. In 1985 we released the State Soil Survey Database, and what that provided the states was a local control of the data. Everything resided in the state office. The computer system that allowed us to edit the 5s and allowed us to edit the 6s were right there on staff. No longer did we have to mail paper copies back to Iowa State. It provided us a database that allowed us to print the reports out, but we still took the time to create the 5, send the 5 to Ames, create the 6, send the 6 to Ames, and then retrieve that information as an entire package for a survey area for that particular need, for which was basically still creating the manuscripts. And all this did was allow us now to move from paper copies into a electronic submission. The State Soil Survey Database was a software that we used to manipulate the Soils 5 and the Soil 6. And when this data came back from Ames, this was called the Map Unit Information Record. This contained all of the information necessary to print out the database reports that we needed for our manuscripts. You'll notice here that this is looking like an Access database, and that's because the OMUR data was converted into an Access when we moved into NASIS. There's only one copy of this MUR data left, and it's here at the National Soil Survey Center in an Access format. Now this particular screenshot shows you the component table and the layer tables, and if you look down through there, I'm still using TX249, which is the Vernon series, and notice the use of layer ID 11 and 12, because those tell you that I had at least 2 different surface textures that I could choose from, and each one of those had a different set of properties. Okay, let's compare the mirror data to the SOLS 5 data, and you'll notice they're an exact duplicate. The one thing that you will notice here is that the Kansas data deviates slightly from the SOLS 5 data. And that's because we're now in the State Soil Survey Database software. And that software allowed the states to manipulate the data inside the database instead of having to send the SOLS 5s and the SOLS 6s up. So we have progressed from a handwritten, typewritten piece of paper that went with the SOIL series to now into a database format that can be manipulated also. The other thing is the State Soil Survey Database provided us was an ability to analyze our data, and we started getting more and more requests for information about where were the salt affected soils and where were the eroded soils and where were the hydric soils. So you can see that now we're moving into a system where our customers are beginning to ask us more and more questions about the data that we have in this database. Okay, we progressed from the before 1972 time to 72 to 85, where we were using SOLS 5s and SOLS 6s. In 85 we began using the 3SD database. Now in 1989 we began looking at what is the next phase of the soil databases. And one of the reasons why we were looking at this is because we wanted a more flexible database. We wanted something that was easier to use than what we had now. We wanted to be able to add new data elements when we needed them. We wanted to be able to have the interpretations run off the actual soil properties. Prior to this, everything was generated out of a rating guide and then manually entered. We wanted to be able to capture all of our data at the field level. Keep in mind, the SOLS 5 was developed at the series level, and it was basically a top-down approach. In NASIS, we wanted to be able to collect the data in the field and aggregate that data to be able to create a series and its set of properties. So we were looking for a system that allowed us to go bottom up instead of top down. We also wanted to be able to customize the reports and the products that were being produced for our customers. Keep in mind, the SOIL 6 limited us to 3 components, and in most cases we knew we had more than 3 components and we wanted to be able to track that information. The SOILS 5 limited us to a maximum of 6 horizons, and we could only report out 4 in the database. We wanted to be able to change that so that we could have multiple horizons. We wanted unlimited components, we wanted unlimited horizons, and we wanted the ability to provide a representative value for modeling. In 1994 we came out with NASIS 1, and this was the conversion of the data from 3SD into NASIS. We had very limited and basic editing capabilities, and we had a NASIS database in each one of the state offices. And this began the annual release cycle of NASIS, in which we were planning every year to have more and more tools available to us. And so we basically separated out a lot of the information from the user interface from the underlying database software. So we had 2 different systems. We had the Informix database and we had the Unix user interface. In 1995 we came out with NASIS 2. And that was 100 years of soil survey, and at that time the NASIS 2 database was valued at $50 billion, which is a pretty expensive little database. This is the time when we added the query and the report writing capabilities. We added cut, copy, paste, and the ability to do global edits. In 1996, NASIS 3.0 came out. That's when we added the interpretation generator. We created the rules and valuations and properties. We developed the calculations and the validations, and along with that we provided the geomorphic description tables so we could have a consistent geomorphology system across the U.S. The next major phase of NASIS came in 1998 when we created NASIS 4.0. Basically what this did was create us a replicated central database in Iowa State, and we were able to have one central location in which all of our data resided. We also added the site and pet-on data structure. We created the edit setups. We added those in, and we also had Soil Survey Scheduler integrated into this, and that allowed us to track what was going on with all of the different surveys. In the year 2000, NASIS 4.1 came out, and we finalized the PET-ON data structure to accommodate the PDP data that was the precursor to the PET-ON program that you see now. In 2001, we came out with NASIS 5, and that's where we added the Sergo export capability, and we consolidated all the databases into a central server. So now we had one central server in which we had all the data reside, and we also created the Sergo data structure and the Sergo export capability that you're familiar with now. NASIS continued its annual releases, and NASIS 5.1 came out in 2002. That's where we added the null hedges to the interpretation generator. We also linked to the NASIS database to retrieve the ecological site information, and we added a metadata repository so that we could manage the data dictionaries that were in NASIS. In 2003, we rolled out NASIS 5.2, and that's where we set forth the staging server, the Sol Data Warehouse, and the Sol Data Mart. This allowed us a publication method for the data that was residing in NASIS. This is also the same time when we created the Sergo 2 data structure, which you're using now. 2005, NASIS 5.3 came out, and that was a pretty significant release that allowed us to use the EAuth and the Citrix. This put NASIS behind a firewall, and it also allowed us to use software that made the network traffic a little bit easier to manage. In 2007, we came out with NASIS 5.4, and that one stayed fairly stable for several years until we moved into NASIS 6. The next major release of NASIS was in 2010 when we released NASIS 6.0. This took a long time to develop because what we were doing was migrating from a Unix environment to a .NET environment. We had to migrate the Informix database to the SQL Server 2005 database, and we converted this from a web-based mainframe database system to a client-server application. The goal of this release was to have full functionality from NASIS 1 to NASIS 5.4. So everything that we had in the previous versions had to be in the NASIS 6 version. NASIS 6.0 gave us a new user interface that mimics the use of Outlook, Excel, and Access, all of the Microsoft products that we commonly use during the day. This screenshot provides you an idea of what the legend, the map unit, and the data map unit component and horizon tables as listed in the tabs on the editor panel. And the component table is opened, and the data in the selected set is the Vernon series. It's that same series that I showed you in previous slides. The obsolete SIR field is on the left-hand column, and it identifies all of this data came from TX249. You should remember that. That was the Sols 5 that I showed you in previous slides. This data was all selected using the same Sols 5 ID number. And if you'll notice, you can see the similarity of the data after 15 years in NASIS. The data hasn't been touched. It's still Sols 5 data. Now, if I open the horizon table, and I can use the sorting and the filtering capabilities that we've got integrated in the user interface. This data is sorted on the top depth, allowing all the horizons in the top depth 0 to appear. And notice the consistency of the TX0249 data in NASIS after 15 years of NASIS. This consistency is due to the foundation of the NASIS data. It all goes back to that same Sols 5. Yeah, some people have gone in there and tailored the data and made new data. They've probably populated fields that weren't on the Sols 5. But the vast majority of the data in NASIS is the same data that came off the original 5. And if you'll look at the Sols 5 that's laid right there and embedded into the image, you'll see it all came from the same source, the Sols 5 database. NASIS 6.0 also moved the database into the MLRA concept of updating Sols surveys, and we did that by splitting out legends, and we now have projects and we have legends. Projects are designed for managing our data. Legends are designed for publishing our data. And I realize it's confusing, but we have all of our management information in the project tables and all of our publication information in legends to try to smooth things out. The goal of the MLRA update is to bring all of these similarly named map units into one common standard that's used across the MLRA. And you'll be hearing more about that in future training sessions. Historically, soil scientists, when they finished mapping a survey, they spent time writing and getting the manuscript published. But today, soil scientists document everything in the databases. So it's imperative that the text notes are used to explain the who, what, when, why, and who cares. And that's the reason why these text fields have been entered into the database, because we are no longer creating manuscripts the way we did. The historical product that we created was the manuscript. The modern product that we create now are soil databases. And so therefore those text notes must be written so that we can try to maintain some information that was the knowledge that we entered into those manuscripts are now entered into the databases. It's imperative to understand the need to rely on the manuscripts as the foundation of the soil's information. Keep in mind that the data that's in the majority of the data that's in NASIS now was converted from 3SD. The only exception to that is anyone that literally created brand new data map units in their initial work after 1995. But for the most part, the database was populated from a Soils 5 and Soils 6 data entry forms. And that information was for a given series, not for a given component. And very few states took the initiative to tailor or edit their data in 3SD prior to being converted to NASIS. So therefore, a great deal of the data that's in NASIS now came from the Soils 5 and Soils 6 vintage of data. And it all has the same set of data. But keep in mind, that is not a map unit concept, because you are limited to the number of components you could put in, and you are limited to the number of layers that you could assign properties to. So the evaluation that you do on the data has to first start with the manuscript, and make sure you read the manuscripts, because the goal behind NASIS has always been to take what we mapped and enter that information into the database and build from the ground up. So during any review of the data, I want you to realize that the manuscripts in NASIS must be reviewed critically and dependently of one another. You have to read the manuscript to look at the map unit description, and then you have to look at the data that's residing in NASIS. And do they match based off of what the manuscript is reporting? Any of the update projects that you create, they are designed to improve the existing product, and that existing product is now a database. So you have to improve the quality of the database and the information that we're delivering. We'll have the ability to do office recorrelations. You're going to hear more about that. And we're going to have the ability to take some of this historical documentation that we've got, PEDONs, transects, lab data, correlation document, manuscripts, and integrate all of that information together to improve the product that we are delivering now. Many soil scientists are still struggling with this MLRA update. And in essence, I'll boil it down to the fact that we have two parts to this update. The first part is going to be to focus on the attribute database. That has been a directive that the division director has put out for the last 3 or 4 years, and we will be moving into an initiative that focuses on cleaning up this attribute database. So we're going to be taking a look at the map unit concept as it flows, and we're going to reconcile these map unit names across political boundaries. We're going to assign a national symbol for all these similar map units that have the same concept. We're going to be doing evaluations that are going to be done on each map unit name, unique map unit name, and we're going to come to some sort of understanding about that map unit and the information that we're going to be providing to the public on them. We're going to fully populate the major components, and we're going to make sure that the strongly contrasting minor components are entered into the database also. And the vast majority of these projects will be office recorrelation projects, where we'll be looking at these map units flowing across the entire MLRA and then making a decision on each individual map unit concept into an MLRA map unit concept. And a thorough review of these map units and their DMUs are going to uncover a lot of similar data sets for each map unit. And the goal is not so much to generalize the data, but to make that data flow, creating a seamless coverage across political boundaries. The second phase of the update is going to be the spatial database. And the spatial update will look at the entire spatial area that particular map unit covers, and we'll have a fully populated database, attribute database, that we'll be able to use to analyze that spatial data. And the intent is that by the time we have the attribute database cleaned up and basically ready for this use, we'll have a various number of spatial tools that allow us to improve that spatial product. So it's not the fact that we don't want the spatial touched right now, it's the fact that the purpose of the first phase of the update is to clean up the attribute data first and foremost. Take that manuscript, take that attribute database, come to an agreement across political boundaries, and then after we've got a cleaner attribute database, we can then move into the spatial database and begin work on that. More to come on that topic. Here's an example of a raster-based modeling from an initial soil survey that the Vermont crew has been working on. This survey team is using an SIE model to identify the components within the landscape, and they're using ground truthing methods to identify the soils and assign the properties. Now, as a division, we're going to be moving towards raster-based products, and the fact is that we're going to be using more and more different products as we move on down the road. But we still have to be able to concentrate and improve that original product, and that's going to be identifying those components and where they are within the landscape. So we got to have a good idea of the components found in the map units and where those components occur on that landform. And that's one of the reasons why we're going to be using this raster-based tool. But why tabular first? Because we have to have a quality attribute database before we can move into some of these other tools that we've got. Here are two examples of where county line joins are so obvious and their need of a recorrelation. The example on the left, it uses Soil Data Viewer to create an interpretive and property maps. And the second example was for the Deepwater project. And if you'll notice, the red arrows shows an obvious bust on that one county in Florida. And if you focus on the properties, we'll be able to improve the quality of the soil survey. But the point is, we've got the tools to easily identify these Frankensteins that we see out there that are located along the political boundaries. And all of us have to realize that we have to clean up the attribute database to make this information flow across the political boundaries so that we don't get these types of misjoins that show up in our national maps. We've got all kinds of spatial tools right now, and a lot of them are pretty complicated to use and only work on small areas, and so they have limitations right now. But the point is, these tools are constantly being developed and they're being improved. And what we're hoping is that by the time we've got a fully populated set of components in an attribute database, that when we start using these new GIS tools, we'll be able to improve the spatial product and have a total product, both spatial and attribute, that we can turn out to the public in a very clean manner. One of the more common questions I'm asked is, why is it tabular first? Well, although this slide presentation is a little old, it says that in the next 5 years we'll be looking at developing raster-based soil survey information. Well, we're already there. In January of 2012, we'll be creating the first national gridded Surgo product. That product will be at either a 30-meter resolution or a 10-meter resolution. And the purpose of that product is to deliver to the soil survey offices for the use in analyzing map unit properties, map unit interpretations, to be able to identify these issues that we've pointed out and how we can reconcile the map unit names and how we can recorrelate some of the map units. Some of these decisions that are needed to be made need to be made on a raster product because it draws faster than the vector products. And ultimately, when we've got this raster perfected, that will be one of the new products that we will be delivering out to our customers, is a raster based